Good morning. I'd like to welcome everyone to our DrillSage roundtable discussion today. I'm Jesse Roy, co-founder of DrillSage, and like most of my distinguished colleagues here on this panel, have over 40 years of experience in the E&P business. Today our panel is going to discuss the practical opportunities we as an industry have to consistently reduce both our risk and cost of our drilling operations, and would reduce these risks and costs by using something new: proactive real-time systems. Proactive real-time systems are a new, proven approach to monitoring wells. Our panel today represents industry expertise from major segments of the industry, including operators, mud logging, well control, drilling, and IT. I'm going to introduce our panel at this point. I'd like to meet Jim Roth, drilling manager for Modern Resources, Jim Streety, the CEO and owner of Spectrum Integrated Well Control, Joel McLong, who represents Geologics, which is a geological software and services company. David Pritchard, my co-founder with Jeremiah Myers, who's also a member of our DrillSage team. David is one of the leading experts and an industry expert recognized around the world for his expertise in drilling technology. And to get started, what I'd like to do is to ask David to tell us, what is a proactive real-time system? What does it do? How is it different? Does it really help us? Or is this just a flash in the pan? David?
Sure. I think one of the things that I've always focused on from a real-time systems platform is the reactive systems we have in the business. When a kick, when a well control incident, when stuck pipe occurs, that is a reaction. We get alarms. What we did and when we designed what we call RTAS, the real-time advisory system, which is our DrillSage product, we wanted to do it keeping in mind that what we needed was a proactive system. So when we thought about that, if you really think about it, our architecture is very similar to the Weather Service. When a tornado, for example, or conditions for a tornado are identified and the physical conditions of the atmosphere are conducive to the formation of a tornado, we get a watch or a watch box. However, when a tornado is actually identified, then we get an alarm. So we modeled our advisory system after that kind of philosophy. In other words, when we get a evolving kick, an evolving stuck pipe incident, loss of barrier, what we're interested in is then identifying that evolution of a watch, as opposed to in the real-time world as we know it, we get an alarm. So we're very much proactive versus reactive. And when you really look at our architecture, what we have then is a system that issues watches and notifications of what is beginning to occur. For example, even down to early kick detection. We're not necessarily interested in detecting a kick early. We're interested in identifying the conditions that allow the evolution of the kick. So that's very much the difference between proactive and reactive. And again, our system has two dynamics: the watch, which again is the evolution of the hazard, and the alarm, which tells you when it's occurring. So we're actually doing both, and that's why it's very different and unique from other real-time systems. There are other aspects, and we'll get into that a bit later as the panel moves ahead. But one of our key focuses will be avoidable lost time. It's a new dynamic in the industry. We want to identify that time from which the first watch occurs to the point that it's either resolved or it actually occurs, unfortunately. So it becomes a leading KPI. And because of the proactive nature of our system is why we can now identify that time that we call avoidable lost time. And that is probably the most learning aspect of our system. So I think that kind of covers, Jay, part of the ground of what we consider a proactive versus reactive system.
Well, I'm going to ask some of the other participants on the panel here. Some of them have had some experience with the DrillSage RTAS product. And open the general question is, would such a system, how would such a system impact day-to-day normal operations? How would it impact the normal cost of day-to-day operations? We all run across stuck pipe issues, lost circulation, overpull, etc., etc., etc. Bread and butter issues that happen virtually daily on drilling operations around the world. How would such a system that we've described impact those costs, the safety, the operations? Jim, do you have any thoughts?
I would say, in its ideal form where the information is available right to at the driller's console, that's probably the single biggest effect. Ironically, you're not going to be able to measure it because if you can catch it there and fix the problem before it happens, you're not measuring anything that's happening, right? That's the ideal place. Later on, if you're 2 or 3 hours into an event and it's still progressing in a bad in a problematic way, and let's say the drilling supervisor catches it, you're still well ahead of the problem and still have time to correct it. And it's that correction time that's probably the single biggest effect that you can have on the operation.
So basically that's going to chop out some cost.
Absolutely. Everybody's operation, everybody knows that their operation is X dollars an hour, X dollars a day. You can break it down to the minute if you wanted. You can simply just take your drilling operation cost for that well and divide it by your days and come up with a number, and then you can just flow that through. It's very easy. You're going to be hard pressed to be less than $5,000 an hour on just about every operation on land. Offshore, it's going to be way more than that, right?
Going to be way more than that. You're right. You're right. Joe, you kind of represent the group that's also right around the well and a lot involved directly in the well operations and on the rig sites. What are your thoughts about how this system might work together to improve the operations or improve the safety or address risk or?
Right. Well, I know that in my experience, I've had many years of customers saying, we need kick detection, Can you provide it? Can you monitor it? Whether it's on the rig, off the rig, or whatever. But again, it comes back to the same thing. It's the alarm fatigue. People are not, kick detection is not effective. That's, as David said, it's after the fact. So we have personnel on the well site, that we've either got well site geologists or mud loggers there on the well site. They are the eyes and ears of the geology department. They're there monitoring what's going on the rig. They're servicing the company man, and they're collecting data. I think the geological component of this is critical in understanding where my formation tops are, how we change, what's the gas ratio issues, or we got CO2, do we get an H2S? The geological side of this can play a major impact, but having this tool will give them the ability to see and add the geological component to that, make better decisions, and be more proactive as the system is. So that's where I see the advantage. The market, it's in the name, right? We're not reactive, we're proactive.
Jim, I know that your background has included a number of stints in various drilling supervisory and management positions around the world, and as well as your well-known expertise in well control. What are your thoughts on this regard?
Well, I think that I want to go back to a little bit of what Joel said and what David said. Let's say we're on the rig today, just as an example. When a reactive system, when you've got a reactive system, is what all the systems are today, the alarm is set for a 5-barrel game. So you've already got a 5-barrel game before your alarm goes off. Now, taking just a rule of thumb, that means that you've got a 15-barrel influx. So by the time they recognize the system and recognize what's happening, you've already, this continues to increase at a rate. So by the time you've actually reacted to it, you could have as much as a 30, 40-barrel influx. And then we go to start it, then at that time we start trying to fight it. And it's what you're talking about your cost savings. If you recognize it in a proactive, you've already got the well shut in. It's a simple circulating it out the choke right there, if that's what you decided that you wanted to do. Again, reactive it's already there, and it's compounded downhill from the surface.